Okay, Assalamualaikum warahmatullahi wabarakatuh. A very good afternoon to all students. Selamat tengah hari, salam sejahtera dan selamat tengah hari. Everybody can listen and see.
Boleh je.
Okay,
Boleh sir.
good. Very good. Okay, now I would like to teach you the experiment number 2, lab number 2. Okay. Remember last time I already told you, lab is always in front of our lecture. Okay. For example, we not yet study the frequency response of the amplifier, but in the laboratory we will do the lab. Okay. Okay, so this is your initiative for each student to learn by yourself the frequency response of the amplifier. Okay. If we look at the lab number 2, experiment number 2, as a normal for student, this is all the theory. Okay. Theory may be a little bit crazy. You need to use a board plot in this lab. Board plot you can download from internet. Later I will show you. And then, okay, now assemble the circuit like this. Okay, the circuit is up to you. The value you want to design, whatever your value. Last week value also can. It's up to you. Okay, now for the 4.1 pre-lab calculation. Okay, follow number 4.12 A to J, calculate at home. Calculate using formula. You can use beta DZ 100. Maybe if you want to use this 3904, its beta is about 204. Oh, it's okay also. How to get beta 100? From you look at the electronic workbench, go to the component, just bring down. And this is the ideal amplifier default. So beta is 100. This one. See, use the ideal one also. Okay. If you don't want, you also can change your value to the component property to N3904. But this one is 200 for beta. Also can. Anything that you can do. This is free for you. Yeah? You can do anything. Don't worry. Okay, now assemble the circuit same like last time in the electronic workbench, but this time we don't have CE. What is the function of CE? CE is bypass capacitor at the emitter R4. When AC comes, CE will short and make R4 become 0. When R4 becomes 0, the gain amplifier become very big. But now the gain is not so big, small, okay? So we don't want to use CE. We only have C in, C out. C2, C1. C2 is the input. C1 is the output section. Okay, now frequency response for low frequency response. Okay, now you already calculate. You already calculate this one. This one you will calculate at home, no problem. Okay, now before you do the high frequency response, the problem is you need to understand this topic. Go to I will upload this notes. I will upload all notes. This note. BJT low and high frequency response comes from the file 1.2 chapter BJT low and high frequency response, Razel Revised 3. These slides. Okay, open this slide and then study this slide. Start from page number 5 to page number. Do the example, page number 20. Then you can do. Okay. If you don't understand, don't study this one, I'm sorry. You will not get the answer. You don't know how to answer the lab. Okay. So must study till page number. Don't go to the high frequency response. Just up to the page number. This one. Page number 13. 1 to 13. Yeah. Okay. Okay. Now, a little briefing about the frequency response of the amplifier. Okay. This one you will study at home. Okay. Okay, now BJT amplifier low frequency response. For the low frequency response, it will give high pass filter. High pass filter like this. AV versus frequency, you plot the graph, you will get the plot like something like this. Many frequency, it will plot a high pass filter response for the low frequency response. So low frequency response of the transistor will produce high pass filter, response. This one write down because this one confusing. The statement is very confusing. So, okay, let's we go a little bit about the low frequency response. Low frequency response, what are the capacitor that in charge to give
Sorry,
the low
the
frequency response? Yeah,
class record tak? Can we record the class?
tak payah record pun tak apa. You tulis. Sebab kalau record, everybody will relax. You write down everything I said, the notes. Record nanti you tak concentrate dalam ni. You will not concentrate. Record also no use because very big size. Difficult to download. Okay, don't worry. Just write down. Write down more effective. Follow. Okay, now low frequency response will give, we call with 3 capacitor that involve in low frequency response. Write down CS, CE and CC. Okay. CS is the input capacitor, C1 or maybe some book say C1, maybe some book say Cin, it doesn't matter. CE is the capacitor across the RE. CC is the output capacitor. Okay, now this 3 capacitor is involved to give the low frequency response. Tulis. Okay, now what are the formula? No need to prove the formula, same like last time. You already AV midband, AV everything need to prove to obtain the equation. No need. Just use the formula because the cutoff frequency is very general formula. You no need to prove. Step by step, no need. Just use. What is the basic formula for the frequency response? Even high or low, the formula is F equals to 1 over 2 pi RC. This is the basic. Very basic knowledge for the F 1 over 2 pi RC. Okay. The component R means here is R input. Okay. And plus also RS. If S RS. But this time your lab no RS. So no need lah RS. Tulis. Write down. So Ri means Z input. Z input means R1, RB parallel with beta RE. Very easy. Finish. Okay, so the input section of the frequency response, FLS equals to 1 over 2 pi Z input time CS. Very easy. Semua faham tak sekarang? Answer. Hello.
Faham sikit, sir.
Faham Nak rekod juga? Okay lah, rekod lah. Rekod tak masuk saya punya email. This morning also I record but nothing reply there. I don't know why. Okay. And then next, I want to calculate the output section of the frequency response. The basic formula is still same. For the low frequency response, C in, C out, and C E involved. Okay. Low frequency response will give what kind of filter? High pass filter. Okay. Later I show you. Okay. So C out formula same also 1 over 2 pi RC. But the component R here is Z out. Okay, now I have RL. So RL plus Z out lah times CC. And Z out is RC parallel with Z out is RC only. No need RO. RO small is neglect. No need. In this case, we ignore. So ZO is RC, let's say. And then the total resistor here, the total resistor of here is RC and RL. So plus for the low frequency response, because the capacitor is in between them. They will make a junction like this one, like a pi network. Okay, because low frequency response is a pi network. Wait, I show you what is the pi network. So you have to plus, no, don't parallel. Wait. Frequency response. Where is the frequency response? No, not this. Oh, ni. This. Okay, don't worry, don't worry. This one is easy. Super children. Okay, we look the example of common base. Don't worry. Okay, I will give you everything. Okay, now common base. Common base also, every amplifier will have frequency response. But in this our lab is common emitter. But we can look any example. Don't worry. Okay, now common base. So input section, you see, like this. And then at low frequency response, it will form like this. 100 ohm to ground, center is 10 micro, 1.2 k ohm to ground, and 9.45 is RE only, because common base only have RE. But our common emitter we have times beta here, because the base, common base and common emitter same circuit, same AC, almost same like this, almost same. You see? So R become 100 ohm. The pi network is input section pi network like this. 100, 10 micro, Z input impedance. So FLS 1 over 2 pi, 100 plus Z input impedance. But in this common base, no Z input is no beta, and also no R1 parallel with RB, R2. So you have to know how to calculate everything. Because in our circuit here, okay, our this one, the maybe I have another notes. Wait, I don't know. Common, I don't know. Maybe common meter loading effect have. I don't know. Not don't know. You have to check the notes every time to time. Don't have. Frequency response is another notes. So you have to learn by yourself. Okay, so you have Z in is beta times RE parallel with what? Parallel with RB, R1, R2. This one, Z in. RS 100, for example. RS we don't have. Oh, no need RS. Very easy. So the formula become 1 over 2 pi Z input impedance times CS. So Z input impedance for this one, whatever. What is it? You already calculate. Z in is R1 parallel with R2 or RB parallel with ZB. You have to, where another notes you have to see. You have to solve this one. You have to look at 3 or 4 notes. Not easy, brother. Not easy. Look another one notes. This one, AC analysis. Remember last time you asked me this one? Oh, not this one. This one. Oi. This one. Wow. And then Z input is RB parallel with ZB in internal. Just use the formula. No need to prove. Oh, I already, this one AB I prove. And then you will get. Okay. Use the formula to find the Z input. And then that's why you need to find the Z in total or ZB. Okay, this is, you will know. You try. If you don't try, you don't know. If you wrong, cut mark. That's all. Easy. Okay, next. This is already pi network. That's why plus, because center of the Bose resistor is, we have the capacitor here. But for no RS also, we have to add the low frequency response. We have to use this formula plus. Okay, how about the output? Okay, output also same. We have the RC, we have the RL. So FLC output, low frequency for the output section, 1 over 2 pi RC plus RL. Very easy. Same like this note. Sorry, this note. Low frequency response. Okay, please do this example first before you go to the lab. You answer the lab. Because this example will make you feel, understand. Page number, slide number 10. Okay. This one. Okay, now you already calculate the AV midband. AV midband means no RS and BS. No need this one. Only RL only. So you calculate the AV midband. You will use the AV midband in the next. Okay. Oh, next. Oh, no need, no need. Okay. Okay. You have to calculate AV midband and AVS also. AV midband means calculation of only RL and no BS and RS. Okay. Then you calculate CS. This is example how to calculate C input section, C output section, and CEE. CEE is formula. Use the formula directly. No need to prove. Frequency response, don't prove. Very difficult. This one. FLE, FL, low frequency response of emitter. So RE small times CE big. RE small means RE big parallel with RS prime. Wow, so many things. Just calculate. Don't prove, okay? Okay, you will get this. Must show everything this calculation, but don't prove everything detail. Just use the formula and show the step by step. Okay, next, finish. Okay, now I already have 3 types of frequency. First, FLS 6.68 Hz, FLC 25.68 Hz, FLE 327 Hz. Which one I want to take? Please take the highest cut off, highest. So take 327. Then change into, during that time, what is the gain? The gain is 3 dB. Gain is this one, 90. AB midband. Don't use ABS. Okay. So 90 and change to 20 dB log, 39 dB. And then I can plot, because he said for the high pass filter response, low frequency response of the amplifier will give high pass filter response. So high pass filter response, look at the, you plot the dB gain versus frequency. Plot lah. Plot like this graph. This. This one for the low frequency. High pass. This is high pass filter response. This one is low pass. Why high? Because more higher frequency, gain become maximum. That's why we call high pass. Low pass filter, more lower frequency, gain become maximum. More higher, you see, higher frequency, gain become small. This one, more higher, higher, the gain become very big. You see, very big. The gain become higher, big. But more lower, gain become smaller. So what does it mean by minus 30 dB, minus 3 dB cut off? Minus 3 dB cut off frequency mid-band gain mean this one. This one is mid-band gain at minus 3 dB, 90. That's mean during this maximum, you change into the dB. This value is dB. For example, maybe, okay, this one. Okay, you already know 90, Okay, 90 at the 3 dB. So 90 at the 3 dB. Here's 90. Okay, now change into the dB first. So 39 actually. During that minus 3 dB is 39 already. What frequency during that time is? We already 327 Hz. 327 Hz. Okay. So you already know that this is the minus 3 dB. So what is the maximum gain for the amplifier for A mid band only, not the ABS, not include ABS. Just plus 3, 41 dB. Very easy. This is all children. Children understanding.
Sir,
Yeah.
yang AV mid band tu,
Ah,
20 tu dapat mana? 20.
kat mana ni? 20
AV,
mana?
AV mid band yang 20 log tu.
Oh, ini formula. This
20
is
tu
only
memang
formula.
fix lah,
Fix,
20 tu.
fix formula.
Okay.
20 log AV mid AV ratio.
Okay, thank you sir.
90 is ratio B over B in. Just time 20 log. 20 log AB ratio. Okay, boleh? Hello. Boleh tak?
Boleh sir, boleh.
Very good. Very good. Okay, finish. Okay, now answer the question. Finish our draft drafting of the board plot. Okay, next. Calculate the value of AB. Oh, calculate. You already calculate just now using this technique, this formula. Yeah, page number 12, finish. Okay, next. Plot. This one plot for the high pass. High pass data response in question B. Okay. Okay, it's okay. Low frequency response, finish. Okay, now I want to use the lab now. Lab simulator. This one all calculation from 4.1 until B, all calculation and draft only. You just sketch the board plot. Start from 4.2, must using electronic workbench. Okay, now connect the circuit in figure 1, set the key. Okay, draw circuit, draw, finish. Okay, draw. Input section, don't use 0.02 because very small. 0.2 volt peak to peak is result. But in the signal generator, change to 0.07 volt because this is the RMS value. This one, 0.7. 0.07, okay? It will give exactly 200 millivolt peak to peak. Okay, start with 1 kilohertz. Okay, start with 1 kilohertz. Okay. Okay, it's okay. Okay, look at the question. Finish. Now measure and record the result for each frequency. Okay, start from 4.2, use graph this. This one is your setup. Setup. You have to use the value. If you want to use the value, you use the value. I give you. Use the setup. Okay. If you want to use your own value, also no problem. Very good. Okay, now use table for question 4.2b. Start from here. 4.2b. This one. Start using the table. Start 20, 50, 100, and so on. Okay, now I start with 20. Okay, start with 20. 20 hertz. Then run. What I want to see, zoom in. Run. Oh, very nice sine wave. Okay, now I want to see what? 20 B input peak to peak all same. Don't change the B input, but change the frequency only. Because this is frequency response. That's why we change the frequency. The output will be smaller or higher. Varied output. We want to change, see the difference of the output when we change the frequency only. Magnitude, same for the input. 200 millivolt or 0.2. So I find here how much be output peak to peak at 0.2 in 20 hertz. Okay. Okay, look at the input. Okay, marker input section is 200 millivolt peak to peak. Okay, look here. BA about 200, 193. About lah. Let's say 200 millivolt. This one 195.9 millivolt. Channel A. Okay. Green color. Okay, now check je red color output. Wow. Red color peak to peak. Positive to negative peak. Okay, finish. So BB is 793. Wow. Put here 793. Millivolt. Millivolt lah. Millivolt. Finish. So easy, like a children matter. Millivolt. Finish. Millivolt. Finish. Okay, next. What is the AB? AB is BO over B in, B output over B in. So 793 over 0.2, I will get 3.9. And then change to dB, 20 log, 3.9. Finish. Seven nine three millivolt, 793 over 0.9. 793. 0.2. 0.2. And then 20 log 0.2. Minus 13.9 dB. Wow. 13. Finish. And then you fill next. Fill out the next. 50 hertz. Change the 50 hertz. And then run. Wow. Input still same. You see input still 200 millivolt peak to peak. Go to the peak. Go to the peak minus. Still 200 millivolt. No problem. Okay, now check the output. Oh, kecilkan sikit. Oi. Peak output, red color to the red color down, negative side. 191 millivolt. Okay, fill here 191. Millivolt. Alamak, susah agak. Millivolt. Okay, now what is the AB? 191 over 0.2. 191 millivolt over 0.2. 0.956. Tak boleh pula. Pasal 0.9. So the gain is 0.9. Change to 20 log dB. Let's change. Negative 0.9. Already big. Negative almost 0 is big. 9 dB. Finish. Okay. Finish. Very easy. Something like that. You fill up everything. Fill up. Okay. And then finish.
So,
And then you,
if
yeah.
0.95 lah, can we write as 1?
Boleh juga. No problem.
Okay, thank you, sir.
And then you will plot. You plot the AVDB versus frequency to this one until you read 0.2. 0.2 here. negative 13, something like that. 0.2 dB, negative 13. You plot, yeah, you know lah, you will get this answer. Exactly, you will get this kind of pattern. So this pattern of graph Bode plot we call low pass filter Bode plot. Okay. Apa low pass filter? High pass filter. Because at more higher frequency, gain become maximum. So it will pass high. This one will be pass low only. Okay, finish. Okay, now finish, and Bode plot finish. Okay, now this come to the another one is high frequency response measurement. For this 4.3 section, you use this one. This same method also 0.2 same, but this time start with 10k, 15k, 50k. Just change 10k. 10 kilo ohm. And then run. Wow. Okay, stop. Zoom in the signal. Wow. Okay. Okay, input section, input magnitude always same, 0.2 volts, 200 millivolt, no problem. Don't change the input, only change the frequency. Look at the output. Output will change by the response. You see? So VB tolak BB, BB is the B section here for output rate. So it is 1.07 volt. Okay. Oi, tepat. 1.07 volt. Okay, AB 1.07 over 0.2. I will get 5.35 and change to 20 log dB, 14 dB. Betul lah. 1.07. Correct. So 20 log 5.35. 14.56. Okay, dB. Finish. And then I fill. I plot. I will get this kind of pattern. Okay. How to plot the graph? This with table graph, you have to plot, not draft, not draft. Using the exactly this one. Download from internet. Bode plot graph. This one, download this one. Maybe here, I don't know which one the better. Maybe here this one better. It's up to you. This one nice. Just download and then you plot. You plot. This one you can change by yourself, your value, no problem. If don't use cache, because this one, this question from this from this one and above. From this 5.4.2 and above, 4.3 and some until finish. Don't cache. Use the Bode plot graph, actual graph. This one. You download any graph you like. Okay, but must be easy to me to see. Okay, understand? Who don't understand?
Sir, can use the Microsoft Word plot or not?
Microsoft Word. Tapi dia tak ada Bode plot. Microsoft Word only give data, table and then plot. Just nice. But I want you to plot manual.
Oh, okay. Thank you, sir.
And then scan, plot manual, pencil and paper. This paper, plot manual by pencil, and then you scan. Then put into the report. Boleh This is group, 4 people, 4 student, 1 group. Very easy. Boleh? Ada lagi soalan? Video I will give you all this video today. Okay, now after that you discuss what this question and then do conclusion. Okay, use the appendix below. Ada apa-apa soalan lagi tak? Senang saja. But even very easy, but you have to go to many notes, especially do this note first, but give you the feeling what is the low frequency response. High frequency response no need to calculate crazy, because high frequency response we don't give you the data for CWO, CCE, CMO, no data. So cannot calculate, just use the lab style. So in this lab, we have two methods. Okay, method number one is calculation. Calculation until here, calculation. This one all for low frequency response until here. Low frequency response of the amplifier will give high pass filter. Remember that. And then second method is low frequency response using software, lab style. And then high frequency response using software, lab style. So high frequency response will give low frequency, low pass filter. I also confused. High, low, low, high. This is crazy. Okay, boleh? Okay, siapa tak faham ni? Any question? Tak ada lah. Stop recording.
Doctor, regarding the submission, when is the submission?
Submission on the Wednesday.
Sir, I have a question. Is that we every week got one lab?
Every week one lab. The lab must always in front of our lecture. You will learn by yourself.
Oh, okay. Thank you, sir.
This is good because if not, you are relaxed. Because online you can see video and relax. No, this is no time for relax. This only procedure. After this, the better way is face-to-face lecture and lab. This is the better one. So you have to learn by yourself. So I design the lab in front of you. You learn all notes. Submit on Wednesday. Okay, nothing else.